Hello class, welcome to the next lesson in 8th grade Eureka Math. Right now we're in Module 7 and today is Lesson 2. Lesson 2 is called Square Roots. It's on pages 15 through 23 in your Module 4 workbooks, so get those pages out and get all your math tools. Get out your math notes so you're ready to copy these details down. Now, square roots is something that we have seen before this year. We've talked about it a little bit when we were studying the Pythagorean theorem and how to solve for a squared variable. And we're going to talk more about it today. Square roots, it's the inverse. It's kind of the opposite of squaring a number. It's if you squared a number, how do you go back, pretty much? So you know 9 times 9 is 81. 9 squared makes 81. Well, square root is when we start at 81 and get 9. It's going the backwards of squaring a number. So our vocabulary, just 2 words today. Square root, which is a number multiplied by itself to form the original number. And so like the square root of 81 is 9, because 9 times 9 makes what we started with, 81. We'll see a couple examples in just a minute, but write down that definition. It is a number multiplied by itself to make the number that we started with. We also have the vocabulary term radical. Now, radical is a word from the 80s. That means cool. But in math, a radical is the square root symbol, or is actually it's the root symbol. Today, we're going to talk about square roots, but you do use a radical for cube roots, for 4th roots, for 5th roots, for 6th roots. But the radical, a lot of people, when they see a radical for the first time, confuse it with a division symbol. It looks something like when you would do long division, what you would use, but it's really kind of like a check mark with another check mark and a line. So this is a radical right here. This is the symbol for taking the square root of something. So right now, today, just know this is the symbol for a square root. Looks kind of like the long division symbol, but it looks more like a check mark. So it's a new symbol that you might have not seen before, but you're going to see it a lot in Module 7. So get used to seeing it, get used to writing it, get used to using it, and get used to finding square roots, like we're going to do today. Today, we will explore the inverse of squaring a number, the square root. So you know squaring a number, like 5 squared equals 25. This is squaring. The inverse, the opposite way, is to say the square root, the radical 25. Radical 25 equals 5. That is the square root. So squaring, you are very familiar with. That's how squaring looks. The square root is just moving in the opposite direction, the inverse direction, the inverse function. I do have it in more detail in these notes at the bottom of the page. So take a look at those notes at the bottom. We have the original number inside the radical, which means the square root times the square root multiplied by itself equals the original number. To put an example with actual numbers, we have radical 81. So 81 is what we start with. We know 9 times 9 makes the 81, makes the original we started with. So 9 is the square root. Well, it is a square root, because square roots can also be a little bit tricky, because -9 times -9 also makes 81. Negative 9 times negative 9 also makes 81 because a negative times a negative makes a positive. So the answer to this, the square root of 81, could be 9 or it could be negative 9. The square root of 81 is 9 or negative 9. It could be either way. But the important part of this is I think today in your work, you don't really have to think about the negative roots. Don't worry. I'm not going to promise it, but I'm going to say you likely will not have to do much negative root stuff in today's lesson. But you will have to know how square roots work. Square roots are the opposite of squares. Like right here, the square root of 81, you need to think in your head, something times something makes 81. I know 9 times 9 makes 81, so the square root is 9. So this is where knowing your math facts will come in super handy. But if you do not know your math facts very well, if you do not know all of these, I did make a little cheat sheet to help you out called, I'm putting it perfect squares and square roots. Perfect squares and square roots. So you'll see on this page right here, I have a little bit of a cheat sheet. I start with 1s, and I went all the way up to 20s. So some of your math facts, 1 times 1 makes 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, all the way up to 20 times 20 makes 400. These are the squares. The black are the squares. The red are the square roots. So the square root of 1 is 1. The square root of 4, the factors are 2. The square root of 3, the square root of 9, the factors are 3. Square root of 16, 4, all the way up to the square root of 400, which is 20. So some of these you probably know. Like I'm going to guess everybody remembers that 10 times 10 makes 100. So the square root of 100 is 10. But maybe once we start getting above 12, because most of the time people teach your math facts to you in 3rd and 4th grade, they stop with 12s. But in today's lesson, you probably will need to know some of these bigger ones. So instead of sitting there with a calculator and guessing, I'm giving you this little paper you can look at. So what I would do if I were you, I would pause the video right now and copy down this chart so that you have something to look at when you're doing today's work. So pause the video, copy all of this down, or you can print my notes from the Google Classroom and just print your own copy. But copy this down so you have it in your notes, so you have a quick study tool. The more you do these, the more you will have memorized. So I have a lot of these memorized because I use them a lot. But if you do not have all 20 of these memorized, it's a good idea to write these down. So write them down now. Okay, hopefully you unpause the video and you're ready to get to work using this chart. So I'm going to keep the chart right next to me as we're working. As we work on exercises 1 through 4. So determine the positive square root of 81 if it exists. So it wants to know the positive square root. So we need to say radical 81. So practice writing the radical of 81. The square root of 81 equals 9. I know this because it's on my chart. I also know because 9 times 9 equals 81. So that is, and I only need to say positive. So it says positive. Remember I told you it could also be negative. In fact, exercise 1 is the exact same thing we did in our notes. 9 or negative 9, but the question is asking just for the positive. So that's it. That's all we're doing. So determine the positive square root of 225. So it wants radical 225. So make sure you're practicing making the radicals. Neat, easy. You need to be precise when you make your radicals so that people know it is a radical and not a division sign. If you are sloppy, your work's going to be sloppy. So the square root of 225 is, you can look at your chart if you want that you copied, is 15, because 15 times 15 makes 225. So this is just practicing right now, getting used to it. The positive square root of negative 36, the square root of negative 36, this does not exist. And the reason this does not exist is because nothing multiplies by itself to make negative 36. Try it. You need something times something to make negative 36. Now you might say, what about 6 times 6? Well, 6 times 6 is 36, not negative 36. Wrong. You might say, well, what about negative 6 times 6? That does equal 36. You are right. But the problem is negative 6 and 6 are different, and that's not how square roots work. Square roots need the same. So 6 times 6 doesn't work because we need it to be negative. And negative 6 and 6 don't work because they are different. And for square roots, they have to be the same. Finally, you might say, okay, Mr. Bader, what about negative 6 times negative 6? Well, a negative times a negative makes a positive again. So we get, and 36 equals negative 36 does not work. So there is no answer to this. This does not exist. Nothing will work. There is no real number that will work for that. 6 times 6 doesn't work because it's not negative. Negative 6 times negative 6 doesn't work because it's not negative. And negative 6 and 6 do not work because they're not the same. And square roots needs to multiply by itself, not by something different. So that was a little bit of a tricky question. It's a good thing I was here to help. Exercise 4, determine the positive square root of 49 if it exists. Well, the square root, remember, practice making a radical, of 49 equals 7, because 7 times 7 makes 49. There we go right there. That is how we work on this. That is how it goes. So that is our 4 exercises. That's practicing making the 36. That's practicing making the square roots, practicing making the radicals, and practice finding the square roots. There is a thing on the discussion right here. What they wanted you to do right here is put things on a number line. So for example, like 1 is the square root of 1. 2 is the square root of 4. 3 is the square root of 9. And 4 is the square root of 16. What were curious about right now is showing you where the other square roots are. So for example, these are what we call the 1, the 4, the 9, the 16 are perfect squares. But you can see, what about the square root of 2? Where does the square root of 2 fit in? Well, the square root of 2 is going to be bigger than the square root of 1 and smaller than the square root of 4. Same with the square root of 3. You can see the square root of 1 equals 1, the square root of 4 equals 2, but the square root of 2 and 3 are going to be decimal numbers in the middle on the number line. The same thing with the square root of 5, square root of 6, and the square root of 7, and the square root of 8. These are not going to be whole numbers. They're going to be bigger than the square root of 4, smaller than the square root of 9. Just wanted me to show you real quick that some square roots are decimals. Some square roots are whole numbers, like square root of 1, 4, 9, and 16 make whole numbers. Some square roots make decimals. So don't just think square roots are always whole numbers. Today, yes, in your work, you're going to see whole numbers. But it is possible for square roots to have decimals. It is possible for square roots to be decimals. Let's look at this a little bit. Let's look at this a little bit more. Starting with exercise 5. Exercise 5 through 9 says determine this positive square root. So again, it wants the positive square root. If the number is not a perfect square, meaning it's a decimal, means if the square root is a decimal, determine which square root would be closest to, and guess and check to figure out a close answer. So let me show you a few of these. Let me show you how this works. Now the square root of 49 is exactly 7. 49 is a perfect square. It is not a decimal. That's it. So that's fortunate. What's not so fortunate is number 6, the square root of 62. Because the square root of 62 is not going to be a whole number. It's going to be a decimal. Because I know the square root of 62 is going to be bigger than the square root of 64. Because I know the square root of 64 is 8, and I'm using my chart to help me. Bigger than 49, and that's going to be 7. And it's going to be smaller than the square root of 64, and that's the 8. So 62 is bigger than 49, which makes 7. 64 makes 8. 62 is somewhere in the middle. The square root of 62 is somewhere in the middle. It's bigger than 7 because 62 is bigger than 49. It's smaller than 8 because 62 is smaller than 64. So we know it's a decimal number, and we can kind of guess how close it's going to be. Because if you look, 62 is really close to 64. So it's going to be close to 8. Because 62 is close to 64, I know this square root is going to be close to 8. It's close there, so it's going to be close here. I know it's close to 8. Now what we need to do is we need to use like guess and check. It's going to be 7 point something, close to 8. So let's guess and check. Where is my phone with my calculator on it? So it is really just guess and check. And we can guess and check because they told us guess and check. So we know it's close to 8. So we know it is 7 point something. So let's try 7.9 times 7.9. That's 62.41. Let's try 7.8 times 7.8. 60.84. Okay, so 7.9 times 7.9 was pretty close. Can we do better? Can we do like 7.88 times 7.88? Okay, we're getting closer to 62. Let's try 7.85 times 7.85. Okay, now we're lower than 62. So let's try 7.87 times 7.87. Ooh, we're getting pretty close. 7.88 times 7.88 was about 9 away. 7.87 times 7.87 was about 7 away. So let's just stop here. and say 7.87. If we want to get closer, we can do 7.875 times 7.875, and we get even closer. But to find it exactly, we're going to spend a lot of time guessing checking. So I'm just going to say this is going to be close enough. Excuse me, because they said 1 or 2 decimal places. So I have it to 2 decimal places. That's where I'm going to stop. But you see, we use what we know to figure out what it's going to be close to. So I knew it was going to be close to 8. And then I started guessing and checking to get something close to it. Let's try it out. Let's try number 7. Let's try another one. Let's try number 7. Now, the square root of 122. Now, on our chart, you'll see that there is no 122. There's a 121 and a 144, though. So we know the square root of 122 is going to be bigger than 121 and smaller than 144. So we know the square root of 122, 121 was 11, 144 was 12. So we know the square root of 122 is going to be bigger than 11 and smaller than 12. But what's it going to be close to? Well, I'm looking at this and I say, well, look at this. 122 is very close to 121. So that's the closer one. That's what it's closer to. So I'm going to say the answer is close to 11. Now, how close? Let's try. Let's try it out. Here we go. I need my calculator back. Let's clear everything. It's close to 11. It's very close. So let's do 11.1 times 11.1. Ooh, that's not 122. Okay. Let's try smaller than 11.1. Let's try 11.05 times 11.05. Ooh, that's pretty close. That's a little bit bigger than 122. Let's see if I put 11.04 times 11.04. That's a little bit, I think 11.05 times 11.05 was closer. I think that was 11, I think that was, oops. Let's look at 11.04 again. About 12 hundredths away. About 10. Okay, I'm going to say 11.05 is probably the closest I'm going to get without going to 3 decimal places. So guessed and checked, 11.05. So it's going to be close to 11 and about 11.05 after I guessed and checked. Might take you a little bit of longer time to guess and check, but you can do it just like me. Exercise 8, square root of 400. Square root of 400. Well, using your chart that I gave you, and this is one of the reasons I gave you the chart, you can see that square root of 400 is 20 exactly. So that just equals 20. Done with that one. Now, number 9, which of the numbers in exercise 5-8 are not perfect squares? Well, number 6 and number 7 are not perfect squares. Because their answers were not integers. They're not integers. And integer means whole number. So not integers means they're not perfect squares. But that's what we're doing today. You can see it's not that bad. You're just doing square roots. And if you use the chart I made for you that you copied, this gets even easier. That chart will help you until you memorize more perfect squares and square roots yourself. That chart will help you. But for the ones that you cannot get perfect, you know, you just got to get close. Just figure out what it's close to, and then use guess and check if they ask you to. But that's the lesson for today. You can see not very long. Square roots, just understand the concept, and the more practice you get writing the radical and getting used to it is the best for you. Lesson summary is on lesson 17 if you want to look at the notes. Exit ticket, let's slide that to the back. Homework helper on page 21, some more examples to help you out. The problem set on page 23, asking you to do exactly what we did. Find the square roots. If there's an exact square root, just write it. If there's not an exact, find the close one. You do not need to use guess and check. Just find the close one. Just find the closest one. Let's see, number 7. Yeah, you can do number 7, and you can do number 8. So you're just getting ones that are close. When you practice, and remember, my answers to the problem set are on the Google Classroom, so you can check your answers with mine. After you check your answers and you are confident, and after you ask me all the questions you have, go back to page 19, your exit ticket. This is what you are going to turn in to show me you understand this lesson in square roots. There are 4 questions on the exit ticket. Do your best. Ask for help if you need it. Excuse me once again. Do your best. Ask questions when you need it. Remember, I'm here for you. Work hard. Don't give up.